안녕하세요 여러분, 김지윤입니다. 제가 지금 와 있는 곳은 미국 대사관저입니다. 하비브 하우스라고 하죠. 정말 특별한 분들을 만나기 위해서 이곳에 왔습니다. 이 항공우주국 나사 그리고 미국 국립대기과학연구소 엔카에서 오신 과학자분들 그리고 엔지니어를 만나러 왔습니다. Good morning, everyone.
Good morning.
So could you please tell us what kind of work you're doing at NASA and NCAR? So Dr. Newman.
So NASA and NCAR are dedicated to doing Earth science. So understanding how both the meteorology and various gases that are natural to the atmosphere and are produced by we humans, how they can impact the atmosphere and of course the surface where we live. So for pollution, for ozone depletion and climate change, how do these gases change the climate of the Earth?
NCAR is a National Center for Atmospheric Research. And what exactly you're working on?
We do weather, climate, and the composition of the atmosphere. So I, in particular, work in the atmosphere composition and chemistry lab. We study the air quality related composition, and then we also study how the composition of the air interact with the circulation impact the climate.
And Mr. Darrow, you're working at NASA.
Yes, that's correct. I'm a special equipment operator for the WB-57, and we carry the experiments that the scientists come up with to altitude and back so that they can collect the research.
Okay, so what is WB-57?
It's a high altitude research platform that NASA operates, and we contract with various government and scientific institutions to transport experiments to near space environments and then back down to the ground. In this case, we're transporting a series of experiments that will sample in situ and collect gases that can be looked at later.
So you're basically flying with the high altitude research aircraft and then collect the data and bring them down and then give it to Dr. Penn and Dr. Newman, and they are going to analyze how polluted our area is. Is that correct?
That's correct.
Because the person like me, when we hear NASA in a car, almost automatically think about like the space shuttle, astronauts, Mars, but you guys are actually studying and doing the research on Earth. I didn't really know that many diverse fields that NASA is working on.
So NASA, it's this National Aeronautics and Space Administration.
Right, the aeronautics.
We not only have a manned spaceflight program, and we have an aircraft program that Don was just telling you about, but we have a lot of satellites that we've put into space. And now satellites can look out at stars and try to find planets and other solar systems and galaxies, but we can turn those same instruments around and look back down on the Earth. And that is maybe more important because, of course, what happens on the Earth affects everybody's life every day. And so Earth science from space is very critical.
So in this case, I think people here are very familiar with the air quality issue that is really at a lower level. So why do we need high-flying aircraft, right? It's because our human activity generates a lot of compounds that they not only pollute, also interact with the radiation and the stratosphere ozone that has climate impact. So the aircraft observation in this case is the essential tool.
Because I thought all the data can be collected by the satellites, but it seems that aircraft is also very important in that case. How high can you fly?
These missions will be flying up to 60,000 feet.
60,000 feet, so 18 kilometers? Or
Yeah, I think that's about right.
Oh, what about the commercial airplanes? How high the commercial airplanes can go up?
Most commercial aircraft cap out around 40,000 feet, with some business jets being able to get into the 50s. But not many other aircraft can get to where we can.
So is it different views? Like from your WB-57 from the commercial airplanes?
It certainly is.
How different?
Well, when you look up, it's black, and you can see the blackness of space. You can start to see the curvature of the Earth. And when you look down, you see a hazy blue, and that actually, for some of our observations, we have to take that blue and correct it out because the way the atmosphere scatters the light, it gives it a blue tint.
So what brought you here, Dr. Newman, and your team?
So we're very interested in seeing gases, particularly man-made gases, that have been emitted at the Earth's surface, but carried up into the upper atmosphere. These gases have implications for climate change, air pollution, and ozone depletion. Eastern Asia, or Korea here, is a very special place because there's this very large circulation that sits over Asia, in particular Tibet. So a lot of gas can come up from the surface and get into this large-scale circulation. But then that air, as it goes around, sometimes gets emitted over the Pacific. And then it actually mixes with the rest of the atmosphere. So Korea is an ideal location to look at this spreading of material from over Eastern Asia into the rest of the global circulation. So we're really, really eager to come here and make these measurements at high altitudes.
I heard that you guys are working on the ECLIP. It's the Asian Summer Monsoon Chemical and Climate Change Impact Project. Is it right?
Yes, yes. So if I add to what Paul just said, so we really are starting a very new study on Asian monsoon. So Asian monsoon is assisting people here familiar with for 1,000 years. Really, it's about the weather.
Right, we call it 장마.
Yeah. So there's a rainfall and the wind direction change. So only in this last 20 years, the NASA Earth observing satellite seeing from space. So then we realized the monsoon is not just what the water is falling down. They also pump a lot of surface air to higher level.
We always thought, well, when monsoon, 장마, comes in Korea, we thought, oh, this is the beginning of the summer. And then after this gone, then we're going to have a really, really hot, humid weather. Yeah. But it's not just the weather thing. I mean, this is something that we have to do the research from the perspective of climate change. And ozone layer, you said. Recently, the ozone hole has been shrinking, and it's almost at the level it used to be, like in 1990s. Isn't it right? Then why but not really in the Asian region?
So the Antarctic ozone hole is, of course, down over Antarctica, and we see it develop every year. The trend is that things are getting better. The reason things are getting better with the Antarctic ozone hole is because the chlorofluorocarbons, the man-made gases that we produced that cause the ozone hole, are going down. And the reason they are going down is because the world negotiated an agreement called the Montreal Protocol.
You worked on that, right?
Yeah, so I am one of the co-chairs of the scientific assessment panel for the Montreal Protocol. The agreement was signed in 1987, and we've been watching a slow decline of many of these gases. All of these gases, we're seeing a slow decline. But these gases have very long lifetimes. Chlorofluorocarbon 12 has a lifetime of over 100 years. So even though it took us a short time to put all these human-produced compounds into the atmosphere, it's going to take a long time for them to go away. But they are going away, and the Antarctic ozone hole is slowly getting better. It'll probably recover back to 1980 levels sometime around 2070. Now, one of the big worries is new compounds are being produced all the time. They're being invented, they're being industrially produced, and a lot of that production comes here in Asia. And so the monsoon circulation that Laura was talking about, these thunderstorms are like elevators that can take the emissions from these chemical production plants and it can pump it into the upper atmosphere very quickly. And then that stuff gets mixed around and it can lead to ozone depletion. So we're worried about this process. Does it cause more ozone depletion? Is it ozone safe? Is it causing more climate change? Is it climate friendly? So that's the reason to be here. So it really does connect to the Antarctic ozone hole. Even though every country in the world has signed the Montreal Protocol, including South Korea, is every nation in the world abiding by it? And this is where the scientists come in. We make the measurements that verify that the countries are doing what they said they would do.
Who to blame?
Who to blame, but also there's a lot of rogue actors. There's a lot of criminals illegally producing these things.
Illegally?
That countries don't know about. So it's up to the scientists to kind of keep our eyes on the atmosphere, to be vigilant, to watch, to see what's happening.
So it's basically that Asia is kind of particular region that emits something that's new hazardous gas, I would say, and it will affect actually all around the world.
Yes.
Is it because Asia is an economic powerhouse?
That's exactly right. And of course, let me point out that a lot of these gases, we live in an industrial society. We need air conditioners. We need refrigerators. So because the Asian countries have developed over the last 50 years, The production plants have been built here and they emit. There are production plants in the US that still emit, and we have to watch those too. So it's a global problem. It's a local problem in terms of emissions, but it's a global problem in terms of impact.
So the pollution problem, in addition to the gas, and also has particles. And these particles and sticky molecules can be lofted up by the monsoon system to higher level. So it becomes much harder to remove the troposphere where we're living in. Wind blow, you can have rainfall and then remove these dirty airs. But once these sticky molecules being lofted to above the storm, and they form a layer of small particles, we call it aerosol. Their effect, either reflecting the sunlight or absorbing the sunlight, will have a large impact globally. So when that change happens, that's what the WB-57 is flying to be below the tropopause to above the tropopause to see how much of man-made gases and particles get into stratosphere.
So you're the one who actually fly across the troposphere, tropopause, and the stratosphere. So did you see any changes while you're flying?
When we're flying, the changes are gradual enough that you don't really see a layer, and a lot of these gases are invisible or too small to see. We don't see a specific change at a layer, but gradually the sky becomes darker. Sometimes we'll see haze on the horizon when we're flying through some especially polluted air.
You know, when they fly, they're above 90% of the atmosphere. They're literally at the edge, the top of the atmosphere. And the temperatures up there are minus 60 to minus 70 Celsius, that the air up there is unbreathable. On top of that, because they're so high, they have to wear full pressure suits. So the suits they wear are effectively space suits that they wear because they're flying so high.
I see. That's why I saw your picture in the spacesuit. Mm-hmm. Wow, this guy is a spaceman. I see. Now
it's required for our aircraft to go above 50,000 feet.
Whenever we hear NASA, then it is located in Houston, Texas, but it seems like there's other branches. So you're in Houston, Dr. Newman, you are in Maryland, and you are in Boulder, Colorado. So all around the country, and the scientists and engineers are working together. That's probably why you can have such an outstanding job and outcomes like this.
And I will remark that we're working with Korean scientists here. There are a number of scientists. In fact, Korea recently launched the GEMS satellite, which is a fantastic satellite. It sits over the equator and it looks down constantly in this area and maps out gases like ozone. The satellites that NASA have, they orbit the planet, so they see Korea once per day for ozone. But the GEM satellite sees everything almost constantly. So this is a brilliant new instrument that's in orbit now. And we're working very closely with Korean scientists, both doing GEMS satellite work, but also ground work. And so that actually it works really well, bringing the aircraft here, but working with the new satellite and the scientists on the ground creates a real synergy.
So the aircraft and also the satellites in the orbiting and also constantly watching in the regions, that it just brings out the best result, I guess.
So it's really a combined effort. I think bringing different capabilities together to work for the entire world.
It sounds like very cooperative in the scientist's world. I hope the political scientists and politicians can work like this, cooperative way, which never happened.
Well, no. For the Montreal Protocol, that has happened. The policymakers and the politicians have signed an agreement. Every nation in the world.
But the more important thing is that you have to abide by it.
Exactly, yes.
Yeah. So how serious the climate change is then?
Yeah, so people think, 2-degree global temperature change is nothing, right? 2 degrees, but that's global long-term average. In that 2 degrees, there's a huge amount of increase of variability. That variability and the location of the rainfall and the small change of the tropics into wider area, all that will cause a very large impact locally.
But still, it's one way to look at it in a bright way, is people are recognizing it and realizing it. But there are still some people say, well, it's not really the serious thing. I mean, this is from the lifespan of Earth, it happens sometimes. So it's just, happening and then it will go away. There are some people saying like that.
Well, the answer to that is that we know carbon dioxide is increasing. Carbon dioxide traps infrared radiation. And so we have seen the temperature of the Earth increase. We've seen sea levels increasing. We've seen sea ice in the Arctic going down. We've seen glaciers in the northern hemisphere decreasing. We've seen water vapor, how much water vapor is in the atmosphere. We've seen it go up, as well as the temperature. It's a challenge, and it's a challenge for industrial society. When we talk about climate change in the past, things that have happened, say, back during the age of the dinosaurs, well, there were no people here. There were no cities here. So in some ways, scientifically, that's interesting, but it's to us today, looking at the physics and the chemistry of what's happening to the Earth. We know the reasons, and we know what's happening, and we can project forward. So we scientists can tell you this. It's not our choice as scientists on what we should do. It's up to people like yourself to determine what we ought to do about it. That's up to you.
The hardest part is always on us.
It's a challenge, but it's a question of political will and the will of people to do that.
Yeah, it is actually, your job is just telling us the fact and the truth. And then it's on us and on the government and the politicians to decide what to do. And that's a really important thing. I actually would like to ask you guys, a lot of private companies are actually jumping into the space program, like Blue Origin and SpaceX and Virgin Galactic. I wonder how the people at NASA feel about it and how they take it.
Well, it's created a lot of opportunities for NASA. We're able to concentrate our efforts further out into the solar system. So we can take our existing resources and move them away from low Earth orbit and into Mars, for example. And we have very good partnerships with SpaceX, Blue Origin, and others, for example, transport of the astronauts to and from the space stations. We're able to, pay for that per the person instead of investing into an entire program for it.
It's only for the government job, but now the private companies are in, so you can do some cooperation with them. Is that
exactly
right? Not feeling threatened at all?
No.
Oh, that's interesting. Because there are some critics, the sending people to the Mars or the space. It's only for the very super rich people. Some new type of leisure. But the NASA, of course, sending people to the space and the moon and etc. But there's something that NASA contributed to the humankind. But what those the private companies jumping into the space program can do for the humankind, that is actually the big question mark for me. Besides sending people to have fun in Mars. Can we go to Mars? What do you think, actually?
I think if we put our efforts to it, we absolutely can.
In my lifetime, do you think so?
I'm not sure.
I think in your lifetime.
You don't know how old I am.
You're 26, I think.
Yeah, right. So how do people in NASA feel about it? I would like to hear from you too.
I'm speaking for myself. I can't speak for NASA on this, but I think it's actually kind of cool. I think it's interesting, it's fun, and it's their money, if they want to spend it that way. NASA can certainly take advantage of it, so we can use these new commercial vehicles to people up to the space station. From a science viewpoint, scientifically, are these companies helping us? Well, not yet, but there are a lot of commercial companies that have helped us build instruments and satellites, and they've done a fantastic job. So the partnership between industry and NASA is very close, but it's mainly for things that NASA wants to do, things that the American government wants to do. Now, putting people into space, Jeff Bezos and so forth, it's kind of fun to see William Shatner go into space, or Elon Musk launching a car into space. I think it's fun. Scientifically, it's kind of neutral. I'm neutral on it.
The B-57 has, we do a lot of reentry observations, and you'll see those on like NASA TV, where we will actually watch space capsules come back in and make sure that they perform correctly, make sure nothing's going wrong, and give that data to the NASA scientists so that they can better understand parachute dynamics or reentry dynamics and things like that. So even though it's a commercial spacecraft coming in, NASA still learns a lot from those. by doing observations.
Well, if there's a lot of space shuttles going up and down, and wouldn't it create another pollution? I'm just curious.
That's an excellent question. And the answer is they do.
They do.
They do produce material that winds up in the atmosphere. And it does have an effect. If you were launching space shuttles hundreds of times per week, then you begin to worry about it. And this is the same problem with the rocket industry in general. We don't know right now how many rockets they'll be launching in the future, but they do leave things in the stratosphere. It's another thing about industrial society that we have to watch out for.
That's a really fascinating story. I never heard of it. I just asked the question out of my ignorance, but you gave me really interesting answers. I would like to hear some fun, interesting stories of yours.